Thank you. Welcome everybody to this side event on Arctic change and global implications of Arctic change. This is the first time that the Arctic Council is arranging a side event, so I should like to underline that the people, and we have a very skillful panel, are speaking on their behalf as experts on Arctic climate change. And the welcome will be given by René Söderman, who is the senior Arctic official of the Finnish delegation to the Arctic Council. So I'll leave it to you to welcome. Thank you.
Thank you, Morten. Thank you for coming here. Ladies and gentlemen, Finland assumed the chairmanship of the Arctic Council in May this year. The point of departure for the Finnish chairmanship program is inclusive cooperation and finding common solutions to common problems. Climate change and sustainable development form the broad framework for our chairmanship program and is supported by all Arctic states, all permanent participants represented in the Arctic Council. And as Morten said, this is the first time the Arctic Council is organizing a side event at the UNFCCC COP. The topic is global implications of an Arctic change. I would like to thank the Finland's Ministry for Environment, the Arctic Council Secretariat, the Arctic Monitoring and Assessment Program for putting this program together. And I would also like to thank Germany for supporting us having this side event here today. Ladies and gentlemen, the last piece of summer sea ice in the Arctic is expected to melt away in just over 20 years from now. In fact, the melt process that affects both Arctic and Antarctic glaciers, ice caps, and ice sheets suggest that the projections of global sea level rise may well be underestimated. These are two important findings of the report Snow, Water, Ice and Permafrost in the Arctic. This report was published earlier this year by the Arctic Council. The third important finding is that changes in the Arctic may be affecting weather in mid-latitudes and even influencing Southeast Asian monsoon. We all understand that the rising concentrations of greenhouse gases that are driving widespread changes in the climate, hydrological and ecological systems in the Arctic. Only last week, the World Meteorological Organization reported that the concentration of atmospheric CO2 levels reached a new record high in 2016. Each year of additional data and research show that change is the new constant. Arctic warming will accelerate climate change globally and exacerbate its implications in all regions. In the north, it means thawing of the permafrost and widespread erosion. Further south, tropical islands may be inundated, and everywhere low-lying coastal areas will be affected. The changing Arctic climate is of great concern for the Arctic Council. At the ministerial in Fairbanks, the foreign ministers noted that Arctic warming is resulting in widespread social, environmental, and economic impacts, not only in the Arctic, but also worldwide. The ministers reiterated the need for global action to reduce both greenhouse gases and climate pollutants, including black carbon. The Arctic Council works hard for the well-being of Arctic indigenous peoples and local communities. It works hard for the sustainable development and the environmental protection in the Arctic region. In cooperation between the Arctic states, the permanent participants and observers, with its 6 working groups, 2 task forces, several experts groups, and with the support of the Secretariat, the Arctic Council has become the major producer of environmental information on the Arctic. This scientific information we share with stakeholders and partners such like the UNFCCC, the IPCC, the IMO and WMO, just to mention a few. We do this to keep the Arctic in the hearts and minds. We do this so we can make better decisions that will shape the future of our generation and the generations to come. Efforts to stabilize global climate will determine the future of humankind. Mitigating climate change will therefore require substantial cuts in global greenhouse gas emissions. It is my sincere hope that the Arctic states, the permanent participants and the observers of the Arctic Council could show example of early ambitious and full implementation of the Paris Climate Agreement. No nation, large or small, will be immune from the impacts of climate change. Whatever we decide to do or decide not to do will affect the Arctic climate, which in turn will affect the global climate system. Dear friends, I would like to thank you for coming here to this event hosted by the Arctic Council with this topic, the global implications of a rapidly changing Arctic. We have a distinguished array of speakers, and I look forward to lively presentations and discussions. Thank you for your attention.
Thank you very much, René. I would like to introduce the speakers. I do think that we have an impressive lineup of excellent presenters today, some of whom are not here yet, or we will connect to remotely. But we have Dave Barber from the University of Manitoba. Dave has been working on sea ice for quite a long time and is really an outstanding expert on sea ice. We will have Petteri Taalas, who is the General Director of the WMO, who will be rushing in about 10 minutes. We have Paul Wassmann, who is a professor at the University of Tromsø. We have Monica Tennberg, who is a professor at the University of Lapland. And last but not least, we have Okalik Eegeesiak, who is the chair of the Inuit Circumpolar Council. So with that, I will give the word to Dave, who will tell us about the recent report, Snow, Water, Ice and Permafrost in the Arctic, which was done under the auspices of the Arctic Council. Thank you.
Good afternoon. Good morning to those of you who are from North America like me and you're having a hard time getting up this early in the morning. I'm going to talk to you a little bit about sea ice, a very little bit, 10 minutes. I've been working in sea ice for almost 40 years now, and I've seen a lot of change happen in the Arctic. I'm in Prairie, Canada, right in the middle of the country, surrounded by wheat fields. You'd wonder why a large marine organization is located there, but just look north from Winnipeg and you'll see Churchill and Hudson Bay. So our province is very connected to the Arctic through the only deep water port in North America being in Churchill. And of course the rail line that connects that is currently in difficulty because of climate change. When I first went to the Arctic many years ago, I used to look at diagrams like this. That was a model projection that was done in the 1980s to look at warming in the northern and southern hemispheres, and I thought I would see some of the earliest signs of climate change in the north based on these model projections. When you look at what our temperatures have been doing on the planet, it sort of looks like this. You've seen these kind of figures before. You've probably also looked on various social media that looked at this boxed area that says there's no global warming going on, there's no climate change going on, there's been a hiatus in global warming since '97. Well, of course, this is just part of the natural variability in the system, and it just remains and continues on an upward trajectory. If we look at observations of the global distribution of temperature, you can take any one of these years. You take 2005, for instance. This is the observed temperature distribution that year, and it's very clearly the Arctic amplification, which I'm sure all of you have heard about. You can look at any of those records over the course of my career, which started in 1981 through to now, and you'll see that Arctic amplification. You can look at it again in 2016, you see the same kind of thing. Talk to the Inuit about this and they see it firsthand where they live and the kind of changes that are going on because of this amplification that goes on at the high latitudes of our planet. And of course, this amplification is happening not just in the summer months, but also in the shoulder seasons and in winter as well. Sea ice is a really good indicator of what's going on with the Arctic climate system because it's a very thin veneer over top of a thick ocean and a thick atmosphere, relatively speaking. So it's best to think of it like the skin of an onion, on the outside of an onion skin. It's really, really thin and very, very responsive to changes that are going on, either forced from the ocean or forced from the atmosphere or forced from both. We're finding that in the summer, we're seeing this decrease in the extent of sea ice, which you've seen before, but I put each of my decades of my own career on there in between those red lines, and you'll see that the variability in the first 10 years of my career was very small, relatively speaking. The next 10 years, the variability went up and the mean went down. The variability continued to go up for the next 10 years, with again the mean going down. This variability is a very key part of the climate system in the Arctic and how sea ice responds to this climate system. We're finding that most of the summer change that we have in sea ice is due to the ice albedo feedback mechanism, which I'm sure all of you have heard of. The ocean is black, sea ice is white, so the ocean absorbs this energy. That's what's happening, primarily driving that summer minimum extent. When you switch this over and you look at the winter extent, it's also going down. So the amount of sea ice we have in the wintertime is decreasing. And interestingly, most of the effects of that are being felt on the Atlantic side of the Arctic. And most of this is an intrusion of warmer Atlantic water in beneath the sea ice, which is affecting the sea ice in wintertime. So we're losing sea ice there. So a lot of my European colleagues are very familiar with this and studying this phenomenon as we move forward. When you think of the impacts of sea ice change, the best way to think about it, or the best way to describe it that I've come up with over the years, is to focus on how sea ice controls light, heat, and momentum. It's very easy to think about light. It's white, so it reflects the energy back to space. If it's not there, that energy gets absorbed by the ocean. The heat, same thing, it insulates the surface. Momentum is how it allows wind to get in and mix things up. If you take a look at a tropical rainforest and you go cut down all the trees, you affect light, heat, and momentum in the tropical rainforest. If you cut down all the trees, you affect everything in the ecosystem. Works the same way in the Arctic. You get rid of the sea ice, you affect everything in the marine ecosystem for exactly the same reasons. So what's happening is this is creating challenges and opportunities in the Arctic, and you have to think of both of those in context. It's not just all doom and gloom. There are some positives as well, and people are adapting to what those positives are and how to take advantage of them. It's affecting large-scale circulation in the Arctic. The Beaufort Gyre and transpolar drift are affecting what we call the switch gate, which happens at the north end of Greenland and Ellesmere Island. And this is really caused by a decrease in concentration, a decrease in thickness, a decrease in extent, and that is causing an increase in velocity. So the ice moves a lot more than it used to. And I'll show you some counterintuitive effects of what happens with that. We're also putting a lot more fresh water into the marine system. And the fresh water has much different characteristics than the marine water, so therefore it affects a lot of processes that are associated with the ocean. We're also finding lots of interesting effects between the sea ice in the marine environment and the continental ice, particularly the ice sheet of Greenland, as well as glaciers that are in the northern hemisphere as well. And this has the potential to affect the Atlantic meridional overturning circulation, which you'll hear a little bit about with one of the other speakers. Storms are increasing in the Arctic. We're seeing an increase event of cyclones, both in the Atlantic sector and the Pacific sector, and this is having very dramatic effects on what happens in the system. We're seeing marine transportation corridors opening. Probably most of you are familiar with the Northeast Passage route along the Russian side of the Arctic, the Transpolar route that goes right across the pole, the Northwest Passage, where we just found the Fury and Hecla recently on the bottom of the ocean floor. And then a lot of people aren't that familiar with the Murmansk-Manitoba Bridge. That's that red line that you see there that goes into the interior of North America. The Northeast Passage route has been open for quite a while now. The Russians are building tankers that will take liquefied natural gas through there. What you see on the top right there is one of the first tankers that's been built. It's the one of 15 that are being built to move natural gas across that northern sea route. China has started to use that route as well for bringing all those things that we don't necessarily need, the 500 different types of toothpaste that you buy at Walmart, that kind of stuff. That's all happening as well. And then, of course, in the North American Arctic, we're getting a lot more tourism. So this is the Crystal Serenity you see on the left there, which is now going through annually in the northern side and that side of things. I want to explain to you two sort of counterintuitive effects that has happened to me personally in the last 25 years as part of my career. The first one is an experience in 2009 when we were taking our icebreaker up this line you see in the center going from L1 up to L3. Those orange colors and red colors are supposed to be thick multi-year sea ice. These are charts that are made from the Canadian Ice Service, and we expected to get maybe 10 or 20 kilometers inside that ice edge and be stopped with our ship. We found out that the ice there was not multi-year sea ice as everybody expected to be. Instead, it was highly rotted, and we were able to transit with our ship at doing 13 knots through that, which is like open water, we do 13.5 knots. We had to go out of our way to find the remnant multi-year ice, where we went into that place called MYI there on 6th of September. And in there we found the remnants of multi-year sea ice tied up to it with our ship. And as we were tied up, about to deploy the researchers onto the ice, we saw waves penetrating into the ice, and it broke up that ice field in literally less than 3 minutes. Broke it all up into very small fields. So a good thing we didn't put all of our researchers onto the ice at that time. This was something we didn't expect to find. It formed a new type of ice, which we now define as rotten ice, and that ice has been in this area of the Arctic every year since then. I'll give you another one. We were just leaving with the Amundsen, which is our icebreaker you see in this animation on the right. We were on our way to Hudson Bay this spring, and we got off the east coast of Newfoundland and ran into ice that looks like this. This ice should not be there at that time of year. It's very thick, multi-year sea ice, pretty much impossible for normal ships to traverse through it. So the Amundsen was taken off its science duties and had to do search and rescue activities. And the reason for it is that we were getting small fishing vessels like you see here stuck in this ice. They were getting punctured from the multi-year flows. They were sinking. There was a lot of damage to shipping equipment. There was a lot of damage to personal health of people. People lost their lives. There was a lot of transiting of ocean ships like you see on the right that were stuck in this kind of sea ice. We made it clear what this ice became kind of a topic of conversation in North America, because you shouldn't see this kind of ice there. And a lot of the pundits were saying, well, this is just a clear sign that climate change is not happening and we're getting all this sea ice off the eastern seaboard of Canada. But in fact, it isn't. What it was caused by was an increased mobility of Arctic ice in the high Arctic, and it exported that ice all the way down the eastern seaboard of Canada to northern Newfoundland because the ice is declining so precipitously in the high Arctic. So it's very much a counterintuitive effect of climate change in this region. So when you think about my own personal perspective of 35 plus years now, I started in the Arctic as a skeptic. I didn't believe that climate change was real. I didn't believe that it was occurring in the Arctic. And it was because the system was still in the natural range of variability of that system. The next 10 years of my career, it came quickly out of that. And the last 15 years has become quite alarmist in the sense that the data and things I present to people are very alarming. I don't consider myself an alarmist. I just happen to be working in a field where there's some very alarming changes going on, and it's time as a nation, as a world, that we started to pay attention to these things. I'm very impressed with the work of Dirk Notts and Julian Struve, who put together this paper just recently, looking at the observed relationship between sea ice and the amount of CO2 that's in the atmosphere. You see a very nice trend that is showing the decline and the correlation between those two features. If you look into the future, when we move to sort of 700 gigatons of carbon dioxide, we can expect a seasonally ice-free Arctic based on observed trends that have happened so far. That happens somewhere in the next 15 to 20 years. We can expect that to happen. We're well on our way towards that right now, and for all intents and purposes, there's lots of the Arctic which is already seasonally ice-free. The changes are ubiquitous, they're happening very rapidly, and there's lots of counterintuitive effects that we have to understand. I'll end there. Thanks.
Thank you very much, Dave. And now we will, Petteri has come, and I'm very proud that you're also on this panel, and we will talk about one of the big topics, one of the new things coming up about connectivities between Arctic climate change and change at lower latitudes. And I think that is one of the most urgent questions to be answered in Arctic science today.
Thank you, and thanks for the invitation to attend your panel. My background is such that I used to deal with Arctic science as a scientist first, and thereafter leading one of the research institutes that was dealing with those issues. And for the past 2 years, I've been working for WMO, and we are also having fairly active Arctic program. And perhaps I can show my slides from here. And so I'm leading now WMO, which is the UN specialized agency on weather, climate, and water, and we are coordinating the global observing systems, and we are very much dealing with national experts. We have about 200,000 experts at the national level, at the Met services, hydrological services, and universities, which are contributing to our work. And we are the fathers of IPCC, and also we were contributing to the establishment of UNFCCC at the Second World Climate Conference. And we are dealing with weather, climate, oceans, and very much observations, and we have about 100 of our members that don't have proper services. And atmospheric research is, of course, one of our cornerstones. And we are dealing with observations, and at the moment we have difficulties that, for example, at high latitudes we have fairly data sparse areas in both hemispheres, and that's preventing the establishment of proper services to that area, and it's also an obstacle for the science in the Arctic. We just published a report in Geneva last Monday stating what is the status of climate and greenhouse gases, and this is an example of carbon dioxide concentration where we have broken 403 ppm last year, and last year we were having the highest annual growth rate of carbon dioxide, 3.3 ppm per year, and the estimation is that this is the highest concentration in the last 3 million years. And since about 1/4 of this carbon that we are emitting to the atmosphere is taken by the oceans, we have already started changing the chemical composition of the seawater, and the cold waters, like in the Arctic, they are stronger sinks for carbon dioxide than the warm waters at lower latitudes, and that's why we have seen this acidification to be most prominent at the high latitudes. Temperature in the Arctic, we have some reconstructions of that, and you can see that we have seen quite unusual features during the last 100 years as compared to the evolution for the past a couple of thousand of years. And we are just reporting what's happening to the global temperature. Actually, we will officially release this report today, and I was already referring to that in my opening statement today, and we have exceeded this 1.1 degree warming level, and this negative trend of temperature clearly continues. And if you look at where these temperature changes have taken place this year, you can see that the high latitudes in the northern hemisphere are the areas where the numbers are the largest, and some of them are ranging between 5 and 10 degrees, like in the European Arctic. There's a special feature south of Iceland as well, which seems that this is a persistent negative anomaly in the temperature time series, and that's most likely related to the melting of Greenland glacier and sweet water intrusion, and which has had a negative impact on the ocean current and from Caribbean towards Western Europe. That's something to be followed carefully in the future. And if we compare what happened 2011 to 2015 with the recent evolution, you can see that this area where we had positive anomalies, it's larger now, and especially this Eurasian Arctic, you can see that this anomaly area is larger than it used to be, and this persistent south of Iceland anomaly is also obvious here. We know that we get more water to the Arctic through the rivers, and this is discharges of the Arctic rivers from Eurasian part of the Arctic and from the North American part of the Arctic. And sea level rise, we have already observed 26 centimeters sea level rise since 1870s, and this rise still continues. And if you look which factors are behind this sea level rise, this thermal expansion is the largest factor behind it. The second is glaciers, but pretty close to glaciers is the melting of Greenlandic ice, and Greenlandic melting is much larger than the Antarctic melting so far, and this reverse discharge type of thing, that's the smallest factor here. And if you look at these changes from 93 to 2004, as compared to the recent 10 years record, one can see that the relative role of Greenlandic ice melting has been dramatically increasing, and that's of course a striking feature for the Arctic. And there was a recent report by U.S. government published just last week, and this is one picture from that publication showing what has happened to the multi-year ice. And here we have first the record. First is from 84, and the second one is from 2016. And you can see that the multi-year ice has practically disappeared, and we don't have practically anymore this 4-year-old ice left. So that's and we have melted about 75% of the sea ice mass from the Arctic. And if you look at the recent evolution, we are not anymore reaching the record levels in the amount of Arctic sea ice, but in the southern hemisphere we have recently broken a record, and this Antarctic melting is a new feature. And the shipping routes, the previous speaker was just referring to them, and one can see that the coming decades we expect to see sea routes open part of the year, and with ice-strengthened vessels one could pass also the North Pole part of the year. And IMF just estimated what is the impact of this so far observed 1 degree warming on the economies worldwide, and one can see that the high latitude area we have more color, which indicates that it's a slight positive impact on the economies, whereas Africa, Latin America, Central America, large parts of Asia and Oceania, they are suffering because of this change. And we have started seeing a growing amount of disasters, and that's valid for storms, it's valid for flooding, and it's also valid for heat waves and droughts. And the WMO is now running a program called Year of Polar Prediction, where we are intensifying the observing systems in the Arctic and also forecasting skills. And one of the challenges is to see what is the impact of the Arctic changes on the weather patterns outside of the Arctic, and it's obvious that it has an impact on the weather patterns in the whole northern hemisphere. But what kind, that needs to be studied further. And this is the campaign of science organizations, Met Services, and WMO is coordinating that campaign from this year until early 2019. And besides that, there's also need for other services on ground, and that's where we are also very much contributing. And finally, what has happened to the pollutants? Some satellite pictures of NO2 for 2005, and here is the similar picture for 2016, showing that, for example, this area of high NO2 concentration, it's spreading northwards, and it has an impact on the Arctic air quality as well. And here's another picture for SO2, which is another pollutant, and this is again 2005 case, and here we have 2016. And you can see more SO2 in the Arctic during the latter case. So it's although we have seen positive evolution outside of the Arctic, one can see that it's not the case in the Arctic. And ozone depletion is not yet over. We expect it to vanish in the coming 50 years, and at the same time, once we are warming the lower atmosphere, we are cooling stratosphere and giving more potential for ozone depletion. And luckily, we have been able to reduce the emissions of ozone depleting gases, and the impact is already slightly seen, but the problem is not over yet. And finally, what's going to happen to the Arctic in the long run? This is the worst case scenario, 8.5 degrees, and especially in the case of winter, we might expect to see even 20 degrees warming in the Arctic in winter time, and in summertime smaller numbers. And same for precipitation. Arctic is the area where we expect to see largest changes in the precipitation, especially winters we expect to see more snowfall there, which may be a problem for various infrastructures. And finally, we need to enhance the observing systems in the Arctic. We don't have enough observations there, and we don't have enough telecommunication systems there, and this POLARSAT type of mission would be needed to comfort that need. Thank you.
Thank you very much, Mr. Taalas. We will now, I think there are two things that one needs to realize, and that is that in the Arctic there are people living. In the Antarctic there are researchers living, basically. And the Arctic is basically an ocean surrounded by water, surrounded by land, whereas the Antarctic is a landmass surrounded by ocean. So what happens in that ocean and what happens to the living conditions of those living in the Arctic will be sort of the theme for the next three speakers. And we will turn to Paul Wassmann to hear more about the ecology of the Arctic Ocean. So Paul, please.
Thank you very much. So this is a little introduction to how the Arctic may function in a principal matter. You see the different land masses and the basins and the currents. And we know also something about the physical oceanography of that area. So that is the different type of currents at the surface down to the bottom. And you see both Pacific and Arctic, Atlantic water masses in red and blue going through that area. So this is something we know about. On top of that water we have ice. This is the winter ice distribution of a particular year, and that is then the summer ice distribution. And between that you have something called the seasonal ice zone. That seasonal ice zone is not very much investigated, to say it politely. It is of the size of 2/3 of continental Europe. And for that ice zone, we may have only a couple of icebreakers and research teams which annually go there. So you can imagine how much knowledge is available from that area. So here you see the seasonal ice zone 30 years ago in brown, and then in yellow you can see how the seasonal ice zone is now, and the white is then the permanent ice in September right now. So between that marginal ice zone, seasonal ice zone is going back and forth. So there's more and more breathing, in quotation marks, in the seasonal ice zone, and the Arctic Ocean is only catching its breath. It also started to hyperventilate, and that type of forcing of the ecosystems is something which we struggle to understand. This is just a reminder that Arctic winds and more open waters change the wind patterns, and that very strongly affects the weather variability. To the right, how it was before, and to the left, how things are right now. And that means we have much more variability all the way down to the Mediterranean, which we hadn't before. So when you hear about different types of weathers, that has something to do with the Arctic, the open waters and the melting of ice. So global warming, forgive me for that picture, but global warming makes the Arctic haunted by what I call 4 apocalyptic riders, and they're affecting the ice cover. And these are warming, ice, light, and freshening, and all those processes change with very great speed. So the sun shines down to something which is here illustrated by this drink. The sun melts the ice, the water gets more and more diluted in the surface, meaning there's less nutrients. So the stratification of that water increases. So ice melt and surface warming, they result in A, more light, more diluted waters, and more stratification. And all that changes plankton and productivity. And I'm an ecologist, so I take more the marine ecosystem point of view here. So when then we go from the south to the north, from the seasonal ice zone to the multi-year ice, you will find along the shelf and in the deep ocean different types of organisms and ice, which we want to understand and to investigate, and we know them not very well. And so the apocalyptic riders, they fundamentally change all the ecological ingredients, all the organisms and all the functions along that transline. But how are they functioning? That is what we want to know, because for the future we would like to adopt and couple with the changes, so we have to know them. So what we need to understand those changes are dedicated, coordinated and system ecological investigations, and through all the seasonal ice zone and through all sectors, not only one on the other sector. We have to comprehend and manage the Arctic Ocean, because along with the changes, also the human use will change. We have to manage that. And first, after this, we will reach what is actually indispensable, and that is what they call pan-Arctic integration or comprehension, an understanding of the entire Arctic, not necessarily in the sector in which you work or your country or research station is situated. And here a little example of how will ice retreat change marine ecosystem in the Arctic. This is the $1,000 question, which we would like to answer. And here is a model investigation which shows you the difference in harvestable production by the end of the century and now. So this is a difference. And you see here an area where we expect that the primary production, the productivity of the Arctic will increase by up to 60 grams of carbon, new production, harvestable production. Then there is a rim around the Arctic where the productivity will also increase, much more slightly. There are areas where the productivity will decrease because of the stratification and the melting of ice. And there is an area where the models say that the productivity will not change very much, despite that the sun is shining when the ice is reduced. So what is to be done, and how do we figure out about the future? Those who are interested in politics will maybe understand what I wrote on the left here. Each Arctic coastal nation needs to define its ice edge and seasonal ice zone. And each nation needs to carry out what I think multidisciplinary research projects in the seasonal ice zone of the sector. And that then has to be followed by a pan-Arctic integration exercise. So this is a picture from Norway, where you see recent ice politics and environmental risk based on political definition of the ice edge of Norway. So you can see that there are different opinions about that between different ministries or NGOs or anything like that. But what we actually have to do, we have to, so to say, for the seasonal ice zone, define our southern limit and then work from that southern limit to the north. And here I would like to give you an example of what is done in Norway. There is something called the Nansen LEGACY, which answers the needs and knowledge for beyond the ice edge of Norway. And it starts with climate change, seasonal ice zone, looks for the fragmented research, which very often makes our research less efficient. We knew for new harvestable resources, like this king crab here. We have to look at the fisheries, petroleum and marine traffic. And of course we need the challenging for forecast and logistics. So you look at the physical drivers, invest them, that is one block of the investigation. You look for the human impacts with regard to Norway, very much fisheries, Norway produces 15 million fish meals a day from the Barents Sea. So that's a lot of fish. We look for what we call the living Barents Sea, north of the ice edge and the marginal ice zone, on what kind of processes there to be found. And at the end, of course, we ask for the future of the Barents Sea and what kind of changes we have to expect in the future. So in order to do that, there is an extensive data collection, which is illustrated to the left, cruise lines and blocks and like that we want to do. And then, of course, the main goal, of course, is to develop predictive tools which we can use for the future. And that predictive tools we have to develop based on the new data which are lacking so far. And nobody can work alone with this science. So in the Arctic, international science landscape is an important thing. And we have already now connections to NABO's Mosaic and Job. But there is, of course, also additional other national projects in which we had to link into to get a complete understanding of the Arctic, not only a sector. So it's a dark or bright future. I think there will be changes in biodiversity. We have to face that. There will be increased fisheries along the Arctic rim and decreased fisheries in adjacent regions. We will have increased oil, gas, or mining options. If we are going to realize those options is another question. We get shorter and more ship transportation. And along with that, we have, of course, also more local pollution. Very much of the pollution now is transported from other areas. And then the question is, how can we make sure that change, increased, shorter and more, does not compromise the sustainability? But in order to understand the sustainability, you have to have a wide understanding of ecosystem function. So the essential for adaptation to change are know the changes that will happen, prepare the inescapable transition between states of the environment, select marine protected areas and take measures to prevent avoidable biodiversity loss, if that is possible, adapt our fisheries to changing productivity, and tune vessels, harbor security options, land-based activities and local population to expected changes in climate economy. So the future can only not happen and you adapt afterwards, but you have to plan what is in front of you and how you are going to tackle that. So what we should base our management on is knowledge-based ecosystem resource management. Thank you very much.
Thank you very much, Paul. This brings us actually to the next speaker and the adaptation to Arctic to change, because it is obvious that it is not only climate change that drives change in the Arctic. It certainly drives the access to the resources, access to the region, access across the region. But in order to try to get a better grasp on what are the other drivers of change, the Arctic Council initiated 3 different regional projects to look at, okay, so we have climate change as one driver of change in the Arctic, but what are the other drivers and how are they interlinked? So Monica, please.
So my topic is adaptation actions in a changing Arctic. And let's put ourselves on the map first. We are in this blue area, talking about that. Barents region covers the northernmost counties of Norway, Sweden and Finland, and northwest Russia. And I'm a political scientist by background, so I will talk a little bit in a different way about these adaptation actions and options. This kind of information that the Arctic is shifting rapidly into a new state. Even with the full implementation of the Paris Agreement, we will see fundamental changes in the Arctic. And despite the mitigation efforts, the Arctic cannot be reverted to its current state has motivated us to think about how the Arctic should adapt to the future decades and things happening there. This is not to say that mitigation efforts are not important, but adaptation is already and will be very essential in the Arctic. In general, this report that we did with 180 researchers from the Nordic countries and Russia agreed that in principle we are well equipped to adapt. We have the resources, competencies, and structures for adaptation. But what is clear is that adapting will be a very challenging task because the Barents region is very different compared to the other Arctic regions. It is the most populated, more than 5 million people living in this area. It has rather well developed infrastructure. It has very different kinds of industries, traditionally reindeer herding, fisheries, forestry, energy industry, tourism. All those things are taking place in this region. So there are already increasing number of land use pressures and competition between different livelihoods and industries. And we have very challenging demographic developments. Our young people are moving away to southern centers after work and education and life in general. The small villages are becoming empty. People are moving to the southern centers. And we have aging populations. I always like to remind here, the age is not the problem. It is the services and infrastructure that people with age, like me, getting so older, need. And this area is also very much interdependent and dependent on developments outside the area itself. The area provides lots of different kinds of resources, both renewable and non-renewable, to international, European, and global markets. Things happening, for example, in European politics, EU-Russian relations, and so forth, have an effect in regional politics there. And there are security concerns very often reported in the media. So all those things make adaptation rather complicated thing. And in this region, we should not only talk about climate change and adaptation to climate change. One of the main findings of our report was that climate change is not the only or the most salient driver of change in the region. It interacts with socioeconomic, political, and cultural changes and provide both opportunities and challenges for people living and operating in the Barents region. And there are also two other complicating issues. The nature of conflicts is changing in the future, we expect to be changing in the future, and governing and cooperation is getting harder. So, as a political scientist, I would like to say that adaptation is a very political exercise, and it's a long-term societal process. It's not evident and clear who will adapt to what, when, and how. Adaptation concerns many societal actors, sectors, and levels of action, and bringing those together to discuss, share information, and agree on the right and proper means to how to adapt is rather another complication in the challenges of adapting. And ideally, we should develop processes and structures that support adaptive governance. The current ideals of adaptive governance are that the governance is responsible, effective, flexible, and collaborative. But how to make that happen in an area which has so many complexities like the Barents region is yet to be seen. But in principle, in this situation of complexity and related uncertainty, what we can do is to improve our adaptive capacity. And this is my simple understanding of adaptation. We have sensitivities and things that we we are vulnerable to, and what we can do is increase our adaptive capacity. And this is a list from our Barents report: engineering, technical solutions and innovation, infrastructure improvements, regulations, economic mechanisms, innovation and entrepreneurship, institutional structures, production practices and routines, cross-sectoral interactions. Those things we can have an effect on. And I would like to say that Nordic countries have and are in the forefront of adaptation planning. This is the way things look where I live in Rovaniemi, in northern Finland, near the Arctic Circle. We have a number of programs running. For example, the Rovaniemi city has a climate program. There's a regional climate strategy for the region where I live in Lapland. We have a national action plan, adaptation plan, and also adaptation is mentioned in the Finnish climate law. In addition, we have lots of things happening internationally and regionally. There's the Barents Climate Action Plan, EU Strategy for Climate Change Adaptation, and Paris Climate Agreement. So in general, you see that there's lots of things happening and quite recent things, and it's mostly, in my view, rather administrative preparatory work with some inclusion of business world and civil society. So I think there's awareness of adaptation needs, but in terms of proper actions and implementation of those plans, we have to see. And what came out of the Barents AACA report was the finding that in addition to these planning exercises and implementation of these plans, we might in the future need conflict resolution mechanisms. There's expectation that in this region things might heat up in a way that these kinds of special measures are needed to bring together different stakeholders, their knowledges, and sharing them and coming up with different kinds of solutions. I would like to claim that the main problem at the moment still is complacency, this idea that we can deal whatever will happen in the future. Maybe it's this part of the fatalistic northern general attitude towards the life. People who have decided to stay in the north feel that they can cope with whatever happens. But I think there are some other more maybe interesting reasons to think about this. And our report came up with listings of barriers and activators of adaptation. And I would like to focus your attention to the activation of the adaptation. And for any people in positions of leadership, locally, regionally, or nationally or globally, I think this is an important list to consider. There are things like attention to the change, observation of real events and weather events, to have engaged officials and residents, direct contact and involvement with research, enabling institutions, livelihood flexibility and diversification, access to knowledge, human and financial resources, capacity building, long-term and short-term perspectives on adaptation. So to conclude, I think the main challenge here is complexity and uncertainty, because we have to deal not only with climate change, but other driving socio-economic forces, and those lead us to the question of sustainable development and sustainability. And also the response to this complexity and uncertainty requires multi-level political and societal processes. And I would like to really wake up people from this complacency. Thank you for your attention.
Thank you very much, Monica. It was nice to hear something about the adaptation that is also going on in the Arctic and in the Rovaniemi region. Used to say that what happens in the Arctic stays in the Arctic. This is absolutely not true for the ice that melts. And we will try to make a brave attempt now to do a Skype conversation with Jason Box, who is professor at the Danish Geological Survey. So please be patient.
Jeg håber, han er der nu.
Ja.
Det kan godt være, der går 4 minutter før.
Yes.
Det ser ud til, at han er der.
While we wait, maybe if there are somebody who has questions to the panel presentation so far, we could take that. This one there. Yes.
Hello.
Oh, we have Jason there. Okay. Good to see you, Jason.
Hello, everyone. Guten Tag.
All right. Are you ready for your presentation?
Yeah, I'm just starting that up, and I think I start in 4 minutes.
Okay, but you can start now, though, if you're ready.
Yes.
Great.
Great. And am I projected to the audience?
Yes, you are.
Okay, hello, everybody. I'm going to switch to share slides. Or share screen, actually. And I've got 10 minutes, is it?
Yes.
Okay. Oops. Okay, so this is Arctic contributions to sea level change. And this work comes from Arctic Monitoring and Assessment Program, which the AMAP, Arctic Monitoring and Assessment Program, has this year coming out a new assessment report which updates us on what new have we learned in the last 5 years since the earlier reports. And what's cool about this is that we have Arctic land ice coming much more into precise focus, where we can say we now have a global land ice inventory that allows us to put the Arctic in context globally. This is kind of a first. And so the changes that we observe at this regional scale, and not including the Greenland ice sheet first, these areas, we have the Canadian Arctic leading as losing the most ice, followed by Alaska, and so on. And I want to draw your attention to the vertical axis going down to minus 600 gigatons of ice loss. The next slide is Greenland, where you have to increase that scale by a factor of 5 for what Greenland is losing. When we compare the full Arctic now, where we have really this for the first time, we find that Greenland is 2/3 of the sea level contribution, the Greenland peripheral glaciers in red, the red pie slice. So that's like 2/3. And then the other collection of Arctic land ice sources is still a significant source. So this loss of land ice has a strong impact on sea level rise. And so here are the global land ice, where you see that Greenland is like almost 4/10 of the global land ice contribution, followed by West Antarctic ice sheet, and so on. So despite the fact that the Antarctica is larger, Greenland is contributing more than a factor of 2 over Antarctica. Now, the global sea level budget, now this is all of the sources of sea level rise. On the far right, the thermal expansion, that has been about 1/3 of sea level rise. We do not expect thermal expansion to grow in the coming decades as fast as the land ice contributions, to where we would add all of the other 3 bars up, and that would be land ice. Actually, minus the thermal, the terrestrial storage, that would be the dark green bar. We do not expect those 2 green bars on the right to change very much, but the land ice on the left, which is driven by the Arctic mainly, we expect to increase. Now, when we consider these 2 scenarios for the future, the red is the business as usual, the blue is something close to the Paris Agreement. We find that even in the Paris Agreement, the Arctic is still warming up quite a lot. In wintertime, 7 degrees by end of century. While there is a difference, an important difference between the sea level impacts that this will create, we're not going to escape all of the Arctic climate change. And so now is a good time to think about how can we more quickly achieve the Paris Agreement, because what that's going to help to do is buy more time into the future. A new thing came up, or something that doesn't get so much publicity, is how global sea level rise is not uniform. You even get sea level drawdown around Greenland, Alaska, and the areas where it's losing mass because there's actually less local gravity there. The water moves toward the center of gravity of the Earth, and it produces a pattern where most sea level rise is in the tropics. The green line is the average of global sea level rise, and you can see in places like the Philippines, Indonesia, Bangladesh, we have like significantly more sea level rise. So sea level rise is not uniform globally. I want to just read some findings for sea level that our work as part of this AMAP SWIPA 2017, we found that Arctic land ice is responsible for half of the global sea level rise in the last century plus. However, in the recent decades, we find more sea level contribution from the Arctic. The third point is maybe the most important, is our ability to project sea level is not where we would like it to be. The best we seem to be able to do today it represents a lower bounds of what sea level rise can be. The reason we can't deliver with today's models a credible upper bounds on what sea level rise could be is the models lack processes that we know what the processes are, but it's very difficult to model into the future so far anyway. This is the challenge to the ice modeling community that's going forward, but our assessment found that we are probably underestimating what sea level rise can be. Also, we don't see any change in the sea level rise until after about 2030, and that's when the difference starts to emerge between Paris Agreement and business as usual. So this is a relatively slow process, and we would be smart to get started early on implementing the Paris Agreement. I think that's the slides I have, and so I will switch back to the other view so that I can talk to anyone. And then I come back, maybe you can see me now. Hello again, everybody. How are we for time? Is there any time for discussion?
Yes, I don't know, will you stay on, Jason, or do you have something else that you have elsewhere that you have to run to?
Not really. I'll stick around. How about that? And if maybe you could point me to the other presenters or somehow make it possible for me to hear, then that sounds
okay.
Nice in our experimenting with video link.
Okay, great. There are some technicians that I hope can help us with that. If there are questions for Jason, I think we could have 1 or 2 questions now. Well, while you prepare, we will. Doesn't seem to be the case, but they may come up later, Jason. So stay tuned, please. So we
Sure.
will. Yeah. So we will. We have heard now, and now we will hear from Okalik, Eegeesiak, from the Inuit Circumpolar Conference, because if anybody should know what happens in the Arctic, it would be the people that have lived there for thousands of years. So, Okalik, please.
Eegeesiak, Okalik Eegeesiak, Inuit Circumpolar Council. Good afternoon. Thank you, and Nat'l to the Arctic Council for organizing this important panel on climate change. I'm Okalik Eegeesiak from Inuit, Nunavut in Canada, representing ICC. ICC was formed 40 years ago to bring the solidarity of the Inuit voice, 160,000 in Russia, Canada, Alaska, and Greenland, to the world, in part to help us to address the environmental changes and challenges we were witnessing at the time, and which have continued to accelerate. We have spent the last 4 decades alerting the world to the impacts of climate change we have been observing in Inuit Nunat firsthand. Inuit have been unrelenting in calling for immediate, cooperative global action on climate change in a way that respects our human rights, our indigenous rights, and our sovereignty. No one created a seat for us at the table in the discussion around climate change. We have created it for ourselves through our vision, our knowledge, and our leadership grounded in the connection to our land, culture, and communities. It is fitting that we as decision makers seek to take stock of where we are in terms of addressing climate change and to make plans to move forward, that eyes and ears turn to Inuit. This slideshow is not really following anything, it's just to help to remind you that there are people in the Arctic. And we do live there, we hunt there, we travel there, and the slides are just to show you that the ecosystem is not just about, what do you call them, praecoactums or whatever they're called, and the animals. It includes the human beings, especially the Inuit in the Arctic. Our strong connections to the land and water sustain our culture and identity and support our physical and mental health. This is my way of explaining that Inuit health and the health of the Arctic environment are inextricably linked. Cultural diversity is as important as biodiversity. Instead of concrete highways, our critical travel infrastructure is the sea ice. Our travel routes spread like a web from each community, extending hundreds of kilometers and creating an enormous network that connects communities across Inuit Nunat. Part of these slides also are attempted to show that we do have a governance system and a consultative system that includes our communities, and we want to be included in the discussions around climate change. And we should be, because we are the ears on the ground. Our dependence on our environment exposes us to the impacts of climate change, which have been more rapid and pronounced in the Arctic, as all of us have said, than nearly anywhere else in the world. We are witnessing this as sea ice is melting, permafrost is melting, and glaciers are melting. Weather is becoming more extreme and unpredictable. Wildlife populations are changing and moving. Our roads and buildings are shifting and cracking with permafrost changes. Changes in the duration, extent, and stability of our ice is making travel more risky and affecting our access to wildlife. Players from outside Inuit Nunaat are increasingly planning ways to take advantage of the opening up of the Arctic caused by climate change, creating a new set of pressures. States and companies see new opportunities to ship across our oceans, extract non-renewable resources from our territories, and harvest renewable resources from our waters in ways that at times appear to forget about our sovereignty and rights to free, prior, and informed consent, as outlined in the United Nations Declaration on the Rights of Indigenous Peoples. Inuit knowledge is not just about how to harvest walrus on an ice floe or how to build an igloo. It is a cultural system of knowledge, skills, values, and beliefs that has much to teach others about how to live well together in this world. It teaches that we are all connected, that an action in one space or time impacts another, even if it's far away. It is through our flexibility and resourcefulness, for example, that Inuit have become adept at bringing together different knowledge systems to find creative solutions to complex problems. Thus, when it comes to responding to climate change in Inuit Nunaat, our feet have been firmly grounded in Inuit knowledge, while our hearts look to creating a world our children and grandchildren can thrive in. We are responding to climate change in our communities by reducing our carbon footprint through energy efficiency and renewable energy developments. We have been adapting our land use planning and infrastructure to respond to permafrost. We have also been building higher quality, durable homes that are adapted to our environment and can better withstand future changes. We are monitoring our wildlife populations and adjusting our hunting and fishing practices to adapt to changes in their availability. We are employing new technology to ensure that our hunters are safe while traveling, such as implementing innovative ice monitoring systems and developing GPS messenger lending programs. Our community-based volunteer search and rescue teams are working with regional and national search and rescue teams to help them serve our communities in the best possible way. We are witnessing the changes and offering our Indigenous science and knowledge to support evidence-based decision-making and develop Inuit-specific management options. A lot of these slides are from work that the Geological Commission did around the North Water Polynya between the High Arctic Canada and High Arctic Greenland, where we are discussing the option of Inuit management systems, Inuit management monitoring, and Inuit management-led research. After a lot of discussions with the communities about how they would like to manage and protect the North Water Polynya. It's called the Geological Commission, and our report just came out about a month ago. For example, as well, we are leading community-based monitoring to know when to apply adaptive measures. We have brought our knowledge and values to the Arctic Council, which has been successful because Arctic Indigenous peoples sit at the table as permanent participants. This is a model to build on and learn from. The Arctic is a model of peaceful settlement. It shows the world different countries and communities can work together for a common good. We need this model today. While countries are increasingly looking inward. Inuit are, as always, looking outward. Here in Bond, as the world comes together again to plan urgent positive action to mitigate human-induced climate change and address its widespread and profound consequences, we see a need and opportunity to bring Inuit knowledge and values forward. Building on commitments in the Paris Agreement, parties will be discussing the operationalization of the Indigenous Peoples Platform. The main purpose of the platform is the exchange of experiences and the sharing of best practices for mitigation and adaptation among Indigenous peoples to strengthen our ability to address and respond to climate change. This also builds on the recognition in the Paris Agreement that adaptation should be guided by science and other knowledge systems, including Indigenous knowledge, and the knowledge in the preamble, and the acknowledgement in the preamble that climate change adaptation efforts have implications on human and Indigenous rights. The Indigenous Peoples Platform presents a huge opportunity not just for Indigenous peoples, but for the UNFCCC process. It ought to serve as a mechanism through which Indigenous peoples fully and effectively participate, so that we are sharing knowledge with each other as Indigenous peoples, but also that our knowledge and practices can lead the way for the world. It ought to provide a vehicle for Indigenous peoples to interface directly with the parties to the UNFCCC, so that we can ensure the obligations with respect to Indigenous rights are upheld. As I said, the Arctic Council is effective because Indigenous peoples are at the table and able to contribute directly to solutions. The knowledge, technologies, practices, and efforts that are shared within the context of the Indigenous Peoples Platform must not be sidelined with the UNFCCC process. There must be a clear link between the platform and the decision-making of parties. Climate change is the monumental collective challenge of our time. It is the most pressing global health issue that we face. It requires all hands on deck, or all hands on the Hamutik, or all hands on the Inuksuk, however you want to understand it. Inuit have demonstrated our leadership, our knowledge, and our capacity to innovate in the most challenging situations. When it comes to climate change adaptation in Inuit Nunat, there is no question that Inuit must be front and center, based on our sovereignty, knowledge, and rights. Inuit are in the Arctic, so work with us. Beyond this, I think it's fair to say that humanity is in a bit of a snowstorm right now. Our Inuit message is that we know the way through this snowstorm. Thank you.
Thank you very much, Okalik. Questions for all of the panel we will now take? Yes, please.
Okay, so my question is to Mr. Barber. Could you shortly explain the link between a cold stratosphere and ozone depletion?
Okay, so the idea is that ozone depletion has been detected in the Arctic because of what's going on in the high atmosphere in particular. So we get a cooling in the upper atmosphere, which changes the chemistry that's associated with the upper atmosphere, and this causes an increase in the ozone hole as we know it. The idea that we're able to adapt to this through, international characteristics where we control the kind of pollutants that are associated with that upper atmosphere chemistry have shown to be effective and can continue to be shown effective. The dynamics, though, of the upper atmosphere are still pretty poorly understood because of some of the characteristics that are going on with some of that photochemistry that goes on at that level. So the exact nature of some of that physics still needs to be understood, so therefore need for ongoing monitoring programs of what these holes look like and how serious they are. Of course, the effects are being seen throughout both the Arctic and Antarctic systems when these things do occur because of UV radiation that is affecting surface-related features that rely on that for photosynthesis.
Thank you, Dave. There's a question over there. Do we have a... I think we'll take you in the second row and then you in the third row afterwards.
My question also concerns... Thank you. My question also concerns the ice sheet and the sea level rise, because my background is biology. I studied biology and specialized in ecology, and there I learned a lot about alternative stable states, which says that if a system is at a certain point where it like swaps into a different state, it's very hard to get back from that. And I'm wondering now if that's the same with the ocean ice, whether it's also in a that kind of transition, and if it's even still possible to keep a certain amount of summer ice or not.
So you're meaning sea ice in particular as opposed to land ice. They work quite differently. And Jason, is Jason still on the line for? Yes. Jason could maybe address the land ice side. I'll address the marine ice side. So we used to think a lot about tipping points in the Arctic, and it was a very common parlance in science. We've tried to get away from it, to be honest, because it's more of a continuous process in sea ice than it is a rapid shift from one stable state to the next. Our planet system has shown that we can have an Arctic marine system with no ice in it. So the planet is capable of managing that kind of condition. Now, we're not suggesting that's going to happen anytime soon. As long as we have darkness in the winter, and as long as the Earth's orbit remains pretty similar to what it is now, we expect to have winter ice cover. But that winter ice cover will be much more similar to what we see in Hudson Bay right now. So one of the reasons we study Hudson Bay is because it's sort of giving us some preordained ideas about what the high Arctic sea ice is going to look like. This idea of going to a seasonally ice-free Arctic, that's the other thing that people like to talk about. They ask, what date is that going to happen? Well, you could see from some of the earlier figures that there's lots of variability in this system from year to year. So as we transition towards this period of the next stable state, which will be one where there is a summer ice-free season and there will be ice in the winter, that could happen any time, really, because we can lose that amount of ice in the summer very quickly. Now, though, we usually use seasonally ice-free in the marine system to be less than 1 million square kilometers of sea ice. So there's still some out there, but it's all piled up against shore, and there's not nearly as much of it, and it's not a real barrier to transportation. And then we expect that state to exist for quite a long time. The idea being that we will always have some sea ice in the winter, even if we look at some of these really dramatic scenarios where we have 10 and 12 degrees sea warming. We're still talking about having sea ice in the northern hemisphere, but you'll go from one where you used to be dominated with multi-year sea ice to one that is dominated by first-year sea ice, which is kind of where we are right now. Then you'll be dominated one where you have really just thin ice. And so if you look at the Baltic Sea here in Europe, and you look at Hudson Bay in Canada, those are transitional states, which we expect the high Arctic will follow a similar kind of trajectory as we move forward. So it's not so much a tipping point, it'll tip back and forth, but it moves towards this new stable state and will continue that way with variability changing as you go through interannually in the next few decades. Land ice.
Thank you. Yeah, thank you, Dave. Yes, we're talking about thresholds and stable states and talking about sea ice and land ice. Could you, Jason, say something about what is the likelihood that land ice, Arctic land ice, would reach a new stable state?
Can you hear me okay? The one factor that is pointing towards irreversibility with Greenland and other land ice is there needs to be a thinning at the highest elevations until those highest elevations draw down into a warmer part of the atmosphere. And that's going to take a long time with Greenland. So it hypothetically does have that irreversibility. I think it's useful to think about what can cool the climate. We do have some circulation that does give us extra snow and add to the land ice. However, I don't see in these projections any significant cooling that we're looking at. We're really looking at a warming system. So it's going to take centuries for the inland part of the ice sheet in Greenland to thin to the point that it really starts melting up at the summit. You can have seasonal melting at the summit, but the dynamic drawdown of the ice will take some time.
I want to mention one other thing quickly on the marine side of the sea ice situation. You can also have reversibility happening on an interannual basis. Like you can have a situation where you have a volcanic eruption, for instance, that cools things locally, and you can get a recovery of the sea ice. Now, that one example I showed in my presentation where we went in, we were actually looking at what we thought was a recovery that year, but it wasn't. It was just the satellites were not detecting it correctly. But the irreversibility of that happens only on an interannual basis. When you look at the decadal kind of thing and multi-decadal, we don't see that it's possible to go back to a multi-year ice-dominated Arctic marine system. We don't think that's physically possible given the warming trajectories we're on.
Thank you, Dave. The next question.
Thank you, first of all, for all your presentations. My question is directed to Professor Paul Wassmann. To what extent should the academic community prioritize fully understanding the increased respiration of the microbial communities in these waters? Of course, with warming, we can expect a higher activity of the microbes in the ocean. Is their cumulative effect negligible, or should it be prioritized that we start understanding that?
I think that the microbial community of those people who work in the Arctic actually have given appropriate priority to that. I can indicate some, you come to me and I tell you some names so that you can approach those people and publications. In years to come, the microbial respiration processes will increase relative to the other ones because of the size of phytoplankton also is changing, and there will be more carbon, terrestrial carbon, into the marine environment. And it's probably the microbial community which will react most of that and make it available or not. So respiration is also now, the respiration in water is now also for the most carried out already by microbial communities. And with an increase of temperatures of about 2 or 3 degrees, of course the respiration will increase much more than the productivity. So things will turn more over to the respiration and microbial side.
Thank you.
Thank you, Paul. There's a question over here. I think that was first.
Hello. I don't know if I need to stand up. I will talk from here. My name is Leonie. Thank you for the presentations. My question is more of a general one. So if I look at the panel, I see mostly scientists, and I think everything that you said in the scientific environment is quite clear already since a few years. And if I look in the audience, I'm quite happy to see a lot of young people. So I think, as Mr. Barber said, these findings or these facts are alarming, and we show that we are alarmed because we are the ones that have to adapt to the consequences. But my question would be, how do you as the scientific community interact with the politicians and with the economic sector, as these are the ones that then actually have the leverage or the potential to decide the necessary steps that need to be done to reduce these impacts? And also, with that, I mean, how do you actively engage with politics and the economic sector? And also from the other perspective, how do you perceive their interests in your findings to include these findings in decision-making processes? Thank you.
Thank you. I think we will have Jason, the question is, how do you as scientists interact with the economic sectors and the politicians and policies? Because the facts that we are presenting here today are alarming, and they need to go further than just to the scientific community. I think we'll start with you, Jason, then have a bit from Dave and from Paul and from Monica as well. So please go ahead.
Okay, Jason here. 2 things. the scientists are delivering reports that are intended audience is policymakers, and so we need to make sure that those reports get in front of the policymakers. Point number 2 is that politicians respond to voters, and so civil society needs to make their voice clear to politicians that through a democratic process, people will vote for elected officials that prioritize science.
I'll try to keep to things that are different than what were described to keep it short. I think there's many different ways that scientists can and do interface with this process. This is one of them where we come here together to share results and things, AMAP with the assessment reports that go on. The idea of engaging with politicians at a direct level, quite often it's a pull on their side, so they want us to come and brief them on different activities. So I regularly give talks in front of members of parliament at the federal level, provincial level, territorial levels, and they're usually a pull. They have a particular problem they're trying to deal with. Unfortunately, a lot of our communication gets down to that level. We're having a problem. How can science help deal with that? And that's a bit of an issue from my perspective. I wish it didn't go to that level. I wish it was a more clear kind of direct communication. Industry works in a very similar fashion. Industry comes to us a lot and says, we're interested in doing such and such. We'd like you to help us on the science side to understand some of the scientific aspects of what are associated with it. I'm at a university which is a good vehicle for that kind of engagement because we can work very independently from industry. I get concerned sometimes when industry don't work with independent science organizations. Instead, they're working with dependent science organizations, and I think that's a problem for us as a society moving forward. And then, of course, the public, it gets engaged right from the very beginning. We have programs on our icebreaker where we bring kids up and we work with Inuit directly on, the 2 knowledge exchange kinds of ideas that Okalik was talking about. They have a lot to teach our youth. We have a lot to teach our youth, and the youth are the ones that are responsible as we move into the future. They're going to bear the brunt of this. So I am also very delighted to see the age distribution that is at a meeting like this. To me, it's very reassuring. We're going in the right direction, and we need to build this momentum and get this change going.
Yes, the connection between politicians and those who deliver the data at the university and so on is kind of complicated. When you go to a conference where you have both politicians and science presented, you cannot present the science before and let the politicians wait, because they have to come first, otherwise they will not come. And then very often they come, and when the science session starts, they walk out. And you can try to improve that, and I would like not to accuse anybody, but I think that the audience, everybody in this audience, we all together are essential to make that connection. The more we demand the connection, the politicians will listen more to those who have to be kind of neutral also, because we have to deliver the best possible data at any time. So we have to be reliable. So I don't want to make policy campaigns, because if somebody comes to me, they should trust that I do the best knowledge on the table, whatever my political conviction is.
Okay, I'd like to try to answer that question too. I think it applies to the Arctic communities just as much as it does to the science community. But first, I'd like to highlight some of the observation that I've started to see lately that applies here as well. We're coming from the face of the polar bear and the seal for the Arctic, representing the Arctic, as opposed to the human face, such as Inuit in the Arctic, and making ice the face of the Arctic now, which is good. I mean, this is what you're interested in. But don't forget the human face of the Arctic, the indigenous peoples of the Arctic. Back to the question about policy development. Industry and governments need to have some confidence the indigenous peoples in our communities in the Arctic. Some confidence in the fact that we know what we're doing up here. We know what we'd like to do with you. We kind of know how to do it, but we need that capacity building that she was talking about as well. That is so needed in the Arctic. We would like resources in community monitoring, community-led research, community-led evaluation, and everything in between. So governments and industry need to have some, some confidence and respect for the indigenous peoples of the Arctic. Thank you.
Thank you, Monica. Monica?
I will take a little bit of a sort of personal approach to this issue and question, because I have a background in doing adaptation-related research for many years, and in the recent years I have become more involved with these strategy-making processes and more political processes. And also I have become more and more frustrated because I see there's so much information, scientific information available, and I don't see it being used. And that's the source of frustration. But on the other hand, I'm increasingly aware that scientific information is only one little piece in the puzzle, because adaptation, in the end of the day, is a very practical, concrete, local thing. So you need lay people's information, their practical knowledge, skills, experiences. What is the best way to build houses, build roads, build whatever you do? We are talking mainly about infrastructure issue. And in order to try to come out of this frustration is to think, I think we need new ways to interact between science communities and political decision-making communities, new ways to discuss and share ideas and proposals, and before we need those conflict resolution mechanisms.
And René?
Yes, thank you. When talking about the collaboration between scientists and policymakers, I believe the Arctic Council is a very good example of how policymakers and scientists come together. Now, what is the Arctic Council? It is basically a high-level forum between 8 Arctic states and 6 indigenous peoples organizations represented in the Arctic Council. The Arctic Council has deep roots both in science and in indigenous knowledge, and in 20 years it has become then, as I said earlier, the major producer of scientific environmental information on the Arctic, or actually on the change happening in the Arctic. So, and then the ministers approve or adopt the recommendations that come out from these 6 working groups that make this scientific work on a 2-year annual basis between the ministerials. So there, I think it works very well, the contact between the science and the policymaking. The fault that the Arctic Council has is that the recommendations that are adopted by the Arctic Council, they are not binding for the national states, for the Arctic states to implement, but at least these issues are brought forward to the ministers. Thank you.
Thank you, René. You had the opening remark, and I will also let you have the closing remark, because I think this is getting this the connectivity between science and what we know and policy is really important. We have placed some food and coffee outside. We will stick around, so those of you who still have questions, please stick around for some food and coffee. There are some flyers on a table down there where you could pick up some of the assessments from the Arctic Council, food for thought. And I would like to thank the panel.